This video shows an application problem involving the computation of the periodic payments in a general annuity. The problem says, what payment made at the end of every 6 months for 15 years will accumulate to $18,000 at 5% compounded monthly. And we notice here that the interest is compounded monthly, but the payments are every 6 months, so there are 2 payments per year. The number of payments per year and the number of conversion periods per year is different. So this is a general annuity. So what we have here is this situation. In 15 years, we want to be able to have at the end, we want this accumulate to 18,000 at the end. So this 18,000 will be at the moment of the last payment. So notice here that the payments made at the end of every 6 months. So at this moment of the last payment, we have $18,000 in this account. How much need to be the payment? And if this is the case, we know the future value. So this 18,000 is the future value, and we know the formula of future value. This formula have R. So with this formula, we can compute this R. The only thing that we need to do is solve for R this equation. And solving for R, maybe you decided to put everything in the formula, and when you have the number that is multiplied by R, solve the equation for R. Or maybe you decided, as I'm going to do it in this way, I'm going to solve for R now. So this I, I'm going to multiply by I the equation, both sides, and I'm going to divide by this number, this factor here, 1 plus I to the power n minus 1. To both sides. So what is going to happen is that R will be, this I appears multiplying this number, multiplying Sn, and this factor here appears here dividing. I put the bracket even that is here, I put the bracket at the bottom. It's not necessary. Human beings understand that this amount here, 1 plus I to the power n minus 1, is actually at the bottom of the equation. So you don't need to put this bracket. But I like it because I want to remember that in using the calculator and solving in just one step, this bracket will be important. So the calculator is going to understand that this is considered as a whole, and you are dividing the numerator by all these numbers. So this bracket is most for the calculator, some scientific calculator that needs this bracket, and I will be showing you how to use it. Okay, so this is the idea, this is the way to compute R. So what we have, we know that the future value is 18,000. Let's put here, future value 18,000. We also know that n is easy to compute. This is actually the number of payments in the annuity, how many payments. And we notice here that there are payments every 6 months. So we are going to deposit this R every 6 months. So K equal to. That happened for 15 years, so 15 times 2 to know n. N will be the number of years multiplied by K. And this is 15 times 2, 30 payments. So we have that n is 30, this number is here. And to compute I, we need to take into account the rate of interest. And we notice that the nominal rate of interest is 5%. 5% compounded monthly, so compounded 12 times per year. You notice here immediately that K and M, number of payments and number of conversion periods per year, are different. So these two indicate that this is a general annuity, and I need to compute the I using this formula. 1 plus the nominal rate of interest divided by the number of conversion periods to the power number of conversion periods divided by the number of payment periods minus 1. So just make a substitution of everything in the formula. Here K equal 2, M equal 12, and R is 5%, 0.05. So when I make a substitution in the formula, this is what I have. And now use your calculator. You notice that this 12 over 2 is 6. So you can use your calculator in just one step. Open bracket, 1 plus 0.05 over 12, close bracket, to the power 6 minus 1. And then you notice that the answer is this, 0.0025261867. This is the number that I put in the memory of my calculator. If you don't remember how to, as soon as you have this number in the screen of your calculator, for example, if you have, let's put the calculator this side. So this number is in the screen of my calculator. I just press here, store. Almost every calculator has a store key. It says store key for storing the memory. So I store. In this calculator, the memories are here, A, B, C, with the green letter. And notice that any key that I press appears here. So when I press store, also notice that the word alpha appears in the screen of my calculator. So now I'm going to press this key here. Whatever memory will work, I'm going to use this memory A. When I press this A, appears that the answer is to the A. It's going to the memory A in the screen of your calculator. Now this number is in the memory of the calculator. Even I can erase or clear the screen of my calculator, but the number continues in the memory. Substituting everything in the formula, so this number will be the I, this Sn is 18,000, and this N here is 30. So making a substitution, that's what we have. How to input this in my calculator in just one step? One step will be better because the answer will be precise. And I know that this number that is too long to write or to type is in the memory of my calculator. So let's see. First we have this number. This number is in the memory A. I'm going to recall A, and this key is for recall. So I press recall, and notice here when I press recall, you see the key that I press it here. And what you notice also that the screen of your calculator appears alpha. Then recall the memory A. So I press A. When I press A, appears in the screen, and now appears the number that is in the memory, 0.025, 26, etc. And then multiply. So I multiply by 18,000, 18000. That put the number in the screen of my calculator, divided by this 18,000, divided when I press division key, so the 18,000 appears here, and the screen is just waiting for another number, divided by this division is this line here, and then the number at the bottom must be in brackets. So that's the reason I left it in this bracket here. So I open bracket. There is another bracket. I open the other bracket of my calculator, and then one plus. Notice when I press the plus, the numbers, the symbol in this calculator go up. The number that I was written and the symbol go to the screen of to the top part of the screen of your calculator. You can go back and correct your mistakes if there are mistakes in the formulas. Okay, anyway, will be plus, again this number is A, the number that is in the memory A, so I'm going to press again recall A, and then close the bracket. So when you close the bracket, the numbers disappear off the screen. And then to the power 30, in my calculator this is the key power, so I'm going to, exponents will be here, so power to the power 30, 30, and then minus 1, minus and then 1. Don't forget to close this bracket, so close the bracket. So you actually have closed both brackets that you open at the beginning. And press the equal signs. So this is 408.29 if we round it to 2 decimal. So let's type the answer. 408.29. $408.29 are the payments that will accumulate to $18,000 in 15 years if you make these payments every 6 months with this interest 5% compounded monthly. Okay, with this I finish my explanation of this problem. I hope you have found it useful. Thank you.